Okay, thanks for coming today and hearing a little bit about digital asset and DAML. What we'll cover today is a bit about contracts. I want to talk about smart contracts, but I think understanding contracts is important. Talk about DAML, which is the digital asset modeling language, about how we write smart contracts. We'll talk about how you might call that from Scala, and then hopefully we'll have some time at the end for some questions. There's a lot of material to cover, so we'll move at a fairly brisk pace today. Okay, a bit about background. I've spent over 8 years doing functional programming, mostly in financial services. I really care about correctness, expressivity, and performance. And I love working in functional programming, which is like Scala and DAML, Haskell, and Clojure. Currently, I work as a developer advocate for DAML at Digital Asset. So my job is to try and make DAML popular, really, people to use it. Digital Asset, we're a technology company. We've got a background in blockchain and financial services. That's where we came from, but we're looking at much broader markets now. And very recently, we open sourced DAML. So DAML's kind of hot off the press as an open source project. It was open sourced a few weeks ago, and that's one of the reasons I'm here talking to you today. We believe at Digital Asset that lots of developer time is spent doing busy work. You know this, you've seen it. And it's not really great to benefit of their customers. So we believe at Digital Asset that using higher level tooling to express your business intent and enable you to be productive as a developer is really, really important. And the other thing is portability. So we've designed DAML to be a portable language that can run across whole varieties of ledgers and substrates. It will run on things like relational databases as well, and we believe that's important for our customers. So a bit of a story to start with. In 1925, a aspiring young businessman called André Poisson in Paris had an interesting opportunity. He was approached by this gentleman claiming to be from the French government, and he claimed that the Eiffel Tower, which had fallen into disrepair at the time, was going to be taken down and sold for scrap. And he thought this was a pretty exciting opportunity. He realised that the amount it was being sold for, he could make a hefty profit and become incredibly rich. And he looked at the paperwork, it seemed in order, so he got a contract and signed it and wired money. He was a victim of a con artist called Victor Lustig. He was quite prolific in the 20th century, and the story is infamous. So the moral is, be careful about the contracts you sign, be careful about who is selling you something, or they own the asset under the question. All these things are very important. And the provenance of things as well. Where did it come from? How can you trace the history of something? So let's talk about contracts. So in terms of talking about smart contracts, I first of all want to go and talk about contracts. And for this presentation, what I did is I did what anybody would do. I went to Wikipedia and saw if I could scrape some text and see what Wikipedia said about contracts. So this is a definition from Wikipedia. And I think it's a good definition of contracts. But what I did is I highlighted the words here that I thought would be useful in terms of talking of smart contracts, because there's some concepts here which I think are important. So contracts talk about parties. These are the people named on the contract. There could be 2 or more people named on a contract. And the people on a contract have rights and duties. So a contract describes an agreement between multiple parties that have rights and duties to each other. Typically, in a contract, we'll talk about exchange of goods. It could be physical. It could even be about promises as well. So a futures option is a contract that describes something that should happen at a future point in time. The other thing is that to formulate a contract, how a contract comes into being, generally follows this type of principle. You have an offer and then an acceptance of the contract. So when you buy insurance, you're offered insurance on a particular term, and then you accept it, and you enter into a contract with the insurance company. And the other thing about contracts is it's mutually entered into of free will. So as people sign contracts, no one's forcing you to sign. You'll sign a contract and mutually enter into that contract of your own volition. And contracts imply obligations. So let's think about some examples of contracts that I'm sure many people in this room have signed employment contracts. Some of the people in this room may have even read their employment contracts. Let's talk about insurance. So insurance is a contract, as I mentioned previously. When you have insurance, as a holder of an insurance policy, you have the right to claim an amount of money in an eventuality, but you have the responsibility to pay the premium. You can probably name all sorts of other contracts. Here's some financial ones: bonds, shares. A bet is a contract when you go to a bookmaker and make a bet. But there's other examples of contracts. It may not be so obvious. I could argue that a protocol execution, setting up a TCP/IP connection, is an example of contracts that are executed by computers. The negotiation of the client between the client server is a very precise set of protocols. When you purchase something in a shop, that's also a contract. You go to a shop, you hand over your money for a good. There's a contract. It might be verbal, it might be fleeting, but there is a contract. And if you hand over the money and the person refused to give you the item, you'll be quite aware of the fact that there's been a breach of contract. What about money? Is money a contract? Well, I'd probably argue it is. So let's look at that in a bit more detail. So everyone's seen a £5 note. You've carried them around in your pockets for ages. But I don't know how many of the people here have actually looked at a £5 note in detail and seen what's written on it. So let's look at a £5 note you've got and the properties it has. There's a legal agreement. Here it says, I promise to pay the bearer on demand the sum of £5. So this is an agreement where you can take your money and get £5. Now in the days of the gold standard, this was important, because you could take your money to the Bank of England and get the equivalent amount of gold for it. There's a signature of the counterparty. So the banknote is signed by the issuer. Here we have the chief cashier who's signed the banknote. There's a security token to stop banknotes being forged. You can see through here. Each banknote has a unique identifier, so you can trace it. You can see if it's been what's in circulation. And banknotes are distributed. There's a distribution mechanism. For banknotes, it's physical. They go into circulation, you can spend them. So what about smart money? How might you model money as a smart contract? Well, we don't have any physical tokens to stop double spend. With a banknote, stopping people spending the money twice is quite easy. Because as soon as you've handed over the banknote, you'd have to take it off the person to hand it over again. But what about electronically? You would need a way of tracking who owns what money. You might want to go and use something like a ledger to do that. You've all heard of systems like Bitcoin that use distributed ledgers. It would need to be created by an issuer. So if I create a banknote and say it was from the Bank of England, I would be arrested because I'd be a forgery. It's the same. There's a legally enforced mechanism to stop in society people creating money. On a digital system and with a smart contract, the issuer would probably want to cryptographically sign that smart money to demonstrate that it came from them. No one else could have created it. And one of the most important properties, I would argue, of money is it's transferable. That's why a currency is a currency. You can transfer ownership. And for convenience, I've added split and merge functionality to that. So I'm going to go show an example in DAML of how you might model money. If you've got, nobody's got laptops here, but we have a little web IDE you can go to and see the example as well. And we also have an SDK you can download. I'll show links later. There we go. Okay, cool. So here is some DAML code. We start off with a template. So IOU means an IOU node. It's like money. A template defines the smart contract, very much like in Scala you would have a class and you'd have an object. It's the same relationship. A contract is something that's been instantiated from a template. And a contract has fields. So, can everybody read this, by the way? Is that text big enough, or? No. Let's see if I can make it bigger. Okay. So, within our IOU template, what kind of things do we want? We want an issuer that we've taught before. In the previous example, the issuer could be the Bank of England. We have an owner. That's the person who's currently in possession of this money. And we can put an amount. We can put other fields in as well, but let's stick with that at the moment. Parties are a special type in DAML. A party means, it's a primitive type, and it means somebody with signing authority. So if you're a party, you can cryptographically sign a contract. That's quite important. The other point is that, well, let's go and say that an amount. So would it make sense for an IOU to have an amount of 0 or negative? I would probably say it doesn't make sense. So I can go and put a little clause in here to ensure that the amount is greater than 0. This means that a contract cannot be created if this invariant is broken. So the amount has to be greater than 0. And contracts should always have at least one signatory. So here we're saying that for this IOU to come into existence, it has to be signed by both the issuer and the current owner. Both of those people have to have signed this contract for it to exist. Now, different people have different rights and obligations in a contract. It's something we talked about before. In this scenario, the owner of the IOU might want to do certain things with it. And I would argue that the owner of the IOU would probably want to be able to transfer it to another person. That's the whole point of currency, is you can move it around and you can change ownership. So here we're saying that the owner can transfer the IOU, and as a result of transferring the IOU, a new contract is created of type IOU transfer. And what we're going to do is when we transfer the IOU, we're going to go and pass the new owner as a parameter. So this means that the owner can now exercise this option on the contract specifying a new owner. In this scenario, we're not actually going to transfer the IOU to the new owner. What we're going to do is we're going to make an offer of transference. So we're going to create an IOU transfer offer. We're going to embed the current IOU as a parameter and pass a new owner. So let's go look at an IOU transfer contract and see what that looks like. So here we have an IOU transfer contract. We can see it has an IOU and it has a new owner specified as its parameters. This IOU transfer to exist has to be signed by both the issuer of the IOU and the owner. Now, different people can do different things. The new owner has two options that are specified. They can either reject the transfer of the IOU or they can accept it. By accepting the transfer of the IOU, we create a new IOU and specify the owner. So what about double spend, I hear you say? Well, what happens is all contracts are in one of two states. They are either active or archived. When a contract's created, it is in an active state. When you exercise a choice on it, the contract itself goes to archived. That means it can no longer be used. So, when this IOU transfer is created, the current IOU is archived and no longer available to be used. Interestingly enough, if you look at the IOU transfer again, the IOU owner can cancel the transfer if the new owner hasn't already accepted the IOU. So if they let them the money out, if they made the transfer in error and said, oh, that's a mistake, and the new person hasn't accepted, I've delegated the right to cancel. So the point is that you can kind of model any level of complex relationship with security with DAML. So you can model smart contracts in a very succinct, easy to express way. Okay, let's go back to... So I was going to go and do an example about what to do with your money and run an insurance example, but I'm not going to do that because I don't think we've got time. But let's go and talk a little bit about the Ledger API. How am I doing for time, by the way?
Yeah, all good.
Good so far? Cool. So we've talked about DAML, which is a model of smart contracts running. DAML runs in a sandbox. It's incredibly tightly controlled. It's got very tight security guarantees on it. It's an immutable language. It's purely functional. The only thing you can really do in the context of a DAML piece of code is archive current contracts and create new contracts. You can't read files, do any I/O or anything like that. So that begs a question: how do you drive a DAML workflow? How do you put data in and get it out? Well, if you look at this diagram, we can imagine DAML running in this blue box. So your DAML contracts running here. It's a virtual shared ledger. And programs can connect in, and there's an API called the Ledger API. It's based on gRPC. It's streaming. And when their party logs in, they log in as their actual credential, as a party. So the Bank of England might log in as the Bank of England. And then they say, well, show me all the contracts where I can see that show me all the contracts that have been created, that I have an option to exercise on that contract. And they get a stream of them back, and then they can decide what they want to do with them in code. So you might write some Scala code here that connects to the ledger, and the new contracts are created, and you can decide what you want to do, what actions you want to take on that. DAML is a full language, and it's a business domain modeling language as well. So for Scala, we've got code to automatically generate domain objects in Scala for the DAML model that you have written in DAML. I'll show that now. So I've taken a little bit of code. There's not time to take you through much else or do a live example, but I just wanted to show you what it might look like. Here we're subscribing to the ledger from Scala. We're saying use an offset to say what point do you want to subscribe from, very much like Kafka. You get given a transaction callback, so you can deal with execute on the transaction. Here what we're doing is we're going through a transaction. A transaction can consist of many contracts that can currently execute in the context of one transaction. And what we're doing here is we're using a generated domain object from the IOU example called exercise IOU transfer accept. So here the Scala code is listening to transfer proposals for it and saying, right, well, I'm going to accept that because I want the money. And that's it really. So that's how you integrate with the that's one of the ways you can integrate with the DAML runtime system from Scala. If you go to DAML.com, you can download our SDK. There's an IDE that's built in Visual Studio Code to write the DAML code. It gives you a little in-memory sandbox. Something I didn't show you before is there's a little test language inside. I'll just bring this up. So here I've written a little what's called a scenario, which is a little inbuilt testing framework that runs in an in-memory sandbox. It allows you to exercise your DAML code and bring up scenario results. You can package your DAML code out and then deploy it onto production systems. And yeah, some links if you're interested. As I said, DAML's fully open source, the language and the runtime. You can check it out on GitHub. We've got a whole bunch of examples. They're mostly financial service orientated, but we'll be adding to that. So I've been building a little poker bot in DAML, which is quite good fun for Texas Hold'em. So that'd be a fun example to put up. We've got a Slack channel, and yeah, you can search for DAML on Stack Overflow. The Slack channel is great. There's usually a whole bunch of us there, and if you have questions, we're quite happy to jump on and answer it.